In today's session, we are going to see about the construction of three-phase transformer. So this is a quick recall about the last class. So in last class, we seen about the single-phase transformers. So here in the single-phase transformer, we seen about the core construction as well as shell type construction. There are two types of core. One is core type, another one is shell type transformer. So whether we can choose either core type or shell type, it is based on the voltage rating. And winding, there are two types of winding. One is primary and secondary. It is both are made up of either aluminum or copper. Mainly we are preparing the copper because of power loss is very minimum. And the cooling system, either it may be an oil or it may be a dry type or it may be a natural air cooling or it may be forced air cooling. And the insulation, mainly we are using the paper or it may be an oil which is used for the insulation. So just to be, this is a recall about the previous class. Okay, so what are three-phase transformer? Why it is more important? So it is very similar to the single-phase transformer. So in a three-phase transformer here, it also work under the principle of mutual induction principle. So here the three-phase input voltage is the energy can be transferred from one circuit into another circuit without changing the frequency. So here we can able to adjust the output voltage level. We can able to adjust the output voltage level by using the electromagnetic induction principle. So compared to single phase, why we are in need of three phase? Because the three phase system is more efficient when compared to the single phase. So here the single phase supply, it may get fluctuated, but in three phase we are always expecting the constant delivery of power. And the single phase can be used only for light load. The three phase can be used for both as well light load as well as heavy load. And here the reduced conducting material compared to the single phase. Okay, so here we are implementing the DT concept. So we have to empathize. So how is different from single phase? The single phase, the three phase transformer, how it is differ from single phase? Okay, and second one, why can't we just use three single phase unit? So we are using three phase transformer instead of three phase. Why we can't use three single phase transformer? Okay, and the third one, so we are having the core type and shell type transformer. So out of core type and shell type, which construction is better for this type? So these are the empathy among the community. So based on this empathy, we have to define so how the electrical energy, the energy can be transferred from one circuit to another circuit without changing the frequency with minimal cost, minimal space and minimal losses. That means at high efficient. Okay, so here the main thing from the requirement, so this should be a compact magnetic circuit, and here the flux distribution among the primary and secondary should be balanced condition, and which is very easy to maintenance and service. Okay, and according to the design construction, the space limitation in the substation, because it requires large space to occupy the transformer, three phase transformer compared to the single phase, and the weight is very high, and transportation also very difficult for the three phase transformer, and the thermal management system is more difficult. So for this way that we can use oil or water, or it may be an natural air or forced air system for the thermal management systems. And this is an ideal stage. So here having the two constructions. Okay, here we are having the two construction. So one is a bank of 3 unit and only 1 unit with the three phase system. So here we are using the bank of 3 unit to make three phase. Here only having the only single unit, it is a three phase system. Okay, so the concept, the three identical single phase transformers are connected, but here having only one transformers can be connected. Okay, and the bank of 3 unit construction, so it is just like a single phase transformer. So here having the three limbs. Okay, so limb 1, limb 2, limb 3, all the three limbs we are connecting both the primary winding as well as secondary winding, which is similar to the shell type transformer. All the three limb having the three windings, totally it consists of 6 winding. So 3 primary and 3 secondary winding will be there. Okay, so it is independent winding. So it has a separate unit with the help of insulation, with the help of the paper, and it will be separated. So all the cores, all the winding will will be separated, so it will be an independent winding. And the external connection for the either to make as a star connected system or to make it as a delta connected system, so the external connections will be taken from the primary and secondary winding for the configurations. And the for a separate tank individual cooling and insulation system will be provided. So this is just like three single phase system to form a bank of three units. And so what is the advantage and disadvantages? So here it will be very easy for the transportation because the unit is very small, so it is easy to transport from one place to another place. And if any fault in the one unit, that particular unit can be alone, it can be replaced, so the spare unit can be available. And the maintenance cost is very low, and also the repairing cost is also very low. And it is very easy to install, flexibility anywhere we can able to install. Yeah, okay. But if you go for disadvantage, so instead of buying single unit, we are buying three unit, so we have to pay higher cost. And more space is required, because if it is separate unit, we need more space requirement. And the copper loss and iron loss, that is constant and variable losses, is very high compared to the single unit. So that if the losses are high, the efficiency is getting low. Okay, so these are the advantages and the disadvantages of bank type. And the on the second one, three phase unit, it consists of only one unit. So we are giving the input to the primary and we are getting the output in the secondary side. So it has only one unit. Okay, so it has three vertical limb and two horizontal yokes. The horizontal is yoke will be there, and it will be a simple one. So it may be we can use a core type, or it may be we can use it as a shell type transformer. So here it has the three limb will be there. It is similar to the bank type. It will be three limb will be there. So in each limb we are connecting the windings, so which is to carry the fluxes, and the common yoke will be there. So we provide the return path for the flux linkages and the cylindrical winding. So for the low voltage and for higher voltage arrangement, so based on that we can make the cylindrical winding can be arrangement, and it will be in rectangular tank to fill the oil for the cooling as well as insulation purposes. So this is a cell type transformer. So it has a totally five limb design. So in the center limb we are carrying the windings, both the primary and secondary windings, and the outer limb which is used to take the flux linkages, which is used for the returning the flux linkages. Okay, so here compared to that, here the weight can be reduced. So this is a comprehensive comparison of three-phase unit. So space and requirement is very low, efficiency is very high, and we are providing the better cooling, and the transportation is heavier. So this is the comparison between the bank type and the three-phase unit. So this is the real world applications. Mainly it is used in the substation and distribution station and the generating station to step up and step down the voltages. And this is a mind map regarding this thing. So we've seen about the three units: bank type transformer, and bank type flexible configuration, and bank type with a recur higher cost, and it is an easy maintenance. So these are the few references. Thank you.